Welcome to solverfy.
Okay, so problem number 5 says to consider a wave function given by psi of x is equal to a sine of kx, where k is equal to 2 pi over lambda. All right, and a is some positive value, some positive constant. So part A wants to know when is the probability of finding this particle described by this wave function a maximum. So the probability of finding a particle is given by the probability distribution, or the for position, which is this, which is given by, if you carry this, a squared sine squared of kx. Okay, so this function will be a maximum when sine, so psi of x squared will be max when sine of kx is equal to 1. So sine of kx will be equal to 1 when kx is equal to n pi over 2, where n is equal to some odd number, 1, 3, 5, so on and so on. So if you see it's at n equals 1, this is pi by 2. Sine of pi by 2 is 1. At n equals 3, this is 3 pi by 2. Sine of 3 pi by 2 is 1, and so on and so on. So now to solve for x, we can plug in k here and say we got kx is equal to 2 pi. Sorry, this is supposed to be a 2 up here. 2 pi x over lambda, which is going to be equal to n pi over 2. So now we just need to solve for x. So x is equal to, bring lambda over, pi's cancel, n lambda over 4. Sorry, where again n is equal to some odd integer, 1, 3, 5, going up. So this will give x is equal to lambda over 4, 3 lambda over 4, 5 lambda over 4, and so on. So that's when at these particular conditions is when this probability distribution, the probability of finding this particle that's described by this wave function, will be a maximum. All right, so now for part B. So for part B, it wants to know when it will be a minimum. Or sorry, not minimum. Well, yeah, 0. When the probability, for which values of x is the probability 0. So again, let's write this down. This is our probability density, or our probability distribution. A squared sine squared of kx. So this will occur when sine, again, so this will equal 0. Psi of x squared will equal 0 when sine of kx is equal to 0. So this will occur when kx is equal to n pi, where n is equal to 0, 1, 2, 3, ... going on. So just integer numbers going out to infinity. So at 0, you get sine of 0 is 0. At 1, you get sine of pi, which is 0. At 2, sine of 2 pi, which is 0. So now let's plug back in to solve for x. We have kx is equal to 2 pi x over lambda, which is equal to n pi. Now we'll just go ahead and solve for x. These pi's cancel, 2 comes over, bring over the lambda, so x is equal to n lambda over 2, where n is equal to 0, 1, 2, 3, ... So, or this will occur when x is equal to 0. Lambda over 2, lambda, 3 lambda over 2, 2 lambda, going on. And then, so at each one of these positions is the probability of finding the particle will be 0.